These are examples for section 10.5, the laws of sines and cosines. Since we deal with triangles so much in trigonometry, we have a system of naming sides and angles that is a little bit more efficient than you may have been used to before. For instance, if we had this triangle here, no matter what kind of triangle it is, we of course name the vertices by uppercase letters. If we name these vertices A, B, and C, then by this system we name the sides by lowercase letters that are opposite those angles. For instance, opposite angle A would be side lowercase a. Opposite angle C would be side lowercase c. And opposite angle B is called lowercase b. This is important because many of the formulas, like the law of sines, the law of cosines, and the area formula we're about to discuss, will cite these particular letters. Example 1. Find the area of triangle ABC rounded to the nearest tenth of a square unit, or U squared. U stands for unit. Here we have triangle ABC. Let's go ahead and name the sides, or identify the sides. Across from angle A is side lowercase a, so side lowercase a is 9 units long. Angle B, opposite angle B, is side lowercase b, which is 11, which is the same as AC. And opposite angle C would be lowercase c, which we don't have. To find the area of a triangle without the height provided, or the altitude, notice this triangle doesn't have an altitude anywhere in it. Remember, the altitude goes from a vertex opposite perpendicular to the other side. When this happens, we can find the area, and we can use one of the three formulas you were introduced to in the notes. In this particular one, we have angle C, and we've got both sides on either side of that included angle. So since this is angle C, we use the formula A equals 1/2 lowercase a, lowercase b, those are these two sides, times the sine of angle C, the angle that we have. So substituting in these values, we have 1/2 times lowercase a, which is 9, b, which is 11, times b, times the sine of angle C, which is 53 degrees. Next, we simplify as far as we can before we must approximate. So 9 times 11 is 99, and then half of that, that's 99 halves, times the sine of 53 degrees. We can go ahead and write this in decimal form. 99 halves, 99 divided by 2 is 49.5, times the sine of 53 degrees. Making sure your calculator is in degree mode, once again, put in your calculator 49.5 times, or just put in sine after that, 53 degrees, close parentheses. We get about 39.532 and so forth. We round to the nearest square unit. Remember, area is in square units, so we get the area is about 40 square units. That means this triangle's area, if you were to place unit long squares inside, there would be about 40 of them. Practice 1. Find the area of the triangle below. Round your answer to the nearest tenth. Pause the video now and try this one on your own. When you're ready, turn the video back on. For practice 1, we have triangle ABC. 17 is represented by lowercase b because it's opposite angle B. Opposite angle C would be 19, so that's C. And opposite angle A is lowercase a, which we don't have. This time we have angle A, so this would be the area formula we would use would be 1/2 times the two side lengths, BC, times the sine of the angle we're looking for, angle A. A equals 1/2 times lowercase b, which is 17, times c, which is 19, times the sine of angle A, which is 135 degrees. From this point on, simplifying the numerical part of this before we approximate, 17 times 19 is 323. We take half of that, which is 323 divided by 2, or 323 halves, times the sine of 135 degrees. Changing this to a decimal, we get exactly 161.5 times the sine of 135 degrees. At this point, we need to approximate, so the area, putting in your calculator, 161.5 times the sine of 135 degrees, close parenthesis, that gives us about 114 square units. So this triangle's area is about 114 square units. Example 2. Solve the given triangle below. Round decimal answers to the nearest tenth of a unit. When solving a right triangle, or when solving any type triangle like this one, remember the term solve the triangle implies that we find all missing measurements. Here we need to find the measure of angle C, we need to find the measure of angle B, and we also need to find side length C, or side length AB. To begin, notice the triangle has one angle measure given, and notice the pattern of sides and angles that are given to us. We have this side given to us, and then as we move around the triangle we have another side. So this would be S, S, and then we have an angle after that. So it's in the SSA pattern. And so we always try the law of sines first before you try the law of cosines. We'll get to cosines later. The law of sines states that side A is to the sine of angle A, as B, side B, is to the sine of angle B, as side C is to the sine of angle C. It's pretty simple. Then we substitute in everything we know. A is 20, because it's across from angle A, over the sine of 115 degrees. We have that angle, equals lowercase b is 11 over the sine of angle B, which we don't know, equals lowercase c across from uppercase C angle, which we don't know, and over sine angle C, which again we don't know. Notice the first ratio has both numbers substituted in, so we definitely will use this. This one has one, not both numbers. This one has neither one of the numbers, so obviously we can't use this one. Since all three of these ratios are equal, it's convenient that we can use any two of them as a proportion. So we're going to take these two, since we've got both terms here with numbers, and here we've just got one, so now we can find the measure of angle B. So I'm going to rewrite that. 20 is to the sine of 115 degrees, as 11 is to the sine of angle B. Now, because this is a proportion, we can cross multiply or use cross products. When I use cross products, going this way, I get 20 times the sine of angle B equals 11 on this other side times the sine of 115 degrees. Now recall, we're trying to solve for B, or angle B. So the next thing we do is need to get rid of the 20 that's being multiplied with it, so we divide both sides by 20. Those 20s divide out there, and we get the sine of angle B equals 11 times the sine of 115 degrees divided by 20. In your calculator, make sure that you're in degree mode But also, be very careful when you start putting this in. It's 11 sine 115. It's crucial that you close the parenthesis on 115 degrees, because if you don't, then it will leave inside that the 20. So put in the parentheses and then divide by 20, just like that. Enter. We round, since we have the sine of angle B, we're looking for an angle. We put in 4 digits, rounded to the 4 digits, so that would be 4 decimal places, 4.4985. At this point, you do what you've learned before. When you've got these 4 digits, you need to get rid of the sine on the angle B. The only way we can do that is take the inverse sine. So we take the inverse sine of both sides of the equation. The inverse sine, or the arc sine of sine B, and over on the right side, take the arc sine of 0.4985. Over on the left side, arc sine and sine undo each other, or cancel each other out, and we're left with the measure of angle B. On the right side, in our calculator, we put in arc sine 0.4985, and we get approximately, rounding to the tenths place, 29.9 degrees. This is one of our answers. Come over to your drawing, put 29.9 degrees into angle B. I'll put parentheses around them to show that these are new values that we found. Also, come up here to your law of sines and go ahead and replace the measure of angle B with 29, or the angle B, with 29.9 degrees. Notice we still have C and sine C over here. We can't use the law of sines right now because we don't have either one of these. So what do? Notice we have 2 angles now out of 3 angles of a triangle. So we go way back. When we learned the triangle angle sum theorem, we can use that simply to find angle C, its measure. So by the triangle angle sum theorem, we have the measure of angle C, which we're looking for, plus 29.9, which is the measure of angle B, plus measure of angle A, 115 degrees, is approximately equal to 180 degrees. It's approximate because we've had an approximation within our problem. Okay, so then to add these together, the measure of angle C plus 144.9 degrees is about 180 degrees. Then subtracting 144.9 degrees from both sides, the measure of angle C is about 35.1 degrees. This is the second answer. In solving our triangle, we come over here to angle C and we put in 35.1 degrees there. And notice now we have angle C's measure, 35.1 degrees. Now we can use the law of sines one more time to find the last missing variable, the side C. We can either use this ratio with this one, since we have this now, or we can use this one with the original one that we used to begin with. I'm going to use these two. So I'm going to rewrite that down. 11 over sine of now 29.9 degrees equals C over the sine of 35.1 degrees. Now we cross multiply and we get C times the sine of 29.9 degrees equals, cross multiplying this way, 11 times the sine of 35.1 degrees. Solving for C, since it's being multiplied with the sine of 29.9 degrees, we divide both sides by 29.9 degrees. Sine of 29.9 degrees. The sine 29.9 degrees both divide out over on the left side, so we solve for C, and we get 11 times the sine of 35.1 degrees over the sine of 29.9 degrees. Again, be careful when you calculate this. When you get to 35.1 degrees, make sure you close off that parenthesis at the end, because if you don't, then it'll take this denominator and calculate it as this top sign. So make sure that you do that. So we have, make sure you're in degrees, 11 times sine 35.1, close parentheses, divide by sine 29.9. I'm going to close that parenthesis too. And we get about, rounded to the nearest tenth, 12.7 units long. This is the third and last answer in our problem. I'm going to come over here and C equals 12.7. So we have solved this we've solved this triangle. It's an obtuse triangle, finding the measure of angle B, the measure of angle C, and side C. Practice 2. Surveying. A surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from the north picnic area in the park to the area of the south picnic area around the lake. Find the length of the bridge. So the bridge is this side of the triangle right here. That's lowercase c. So in this one, we're not actually solving the entire triangle like we did on the last one. We're just finding the length of C. So find C. Notice the pattern of sides and angles that are given to us. We have two angles and a side given to us. The side is included in between the two angles. So this has got the pattern of angle, side, angle. So the ASA pattern, notice that pattern, it's going to be important later. So see if you can do this problem, finish it out, finding the length of C, and then turn the video back on when you're ready. Okay, in this surveying problem, we're looking for the length of the bridge, C here. So we're going to start with the law of sines. So remember, that's A over the sine of angle A equal B over the sine of angle B equals C over the sine of angle C. Substituting in everything we know, notice that little a we don't have, so A over sine A, that's sine of 71 degrees, equals lowercase b would be opposite angle B, so that's 150, over the sine of angle B, which we don't know, equals C, little c, which we don't know, over the sine of angle C, which we do know, 60 degrees. Notice that none of these have both numbers. You've got A, you've got sine B, and you've got C. So what do? Well, we already have two angles, so we can find by the triangle angle sum theorem one of the remaining angle, since we've got two of them. So we do that first. So we have the measure of angle B is what we're looking for. So this will be replaced. Is plus, the measure of angle A is 71 degrees, plus the measure of angle C, which is 60 degrees, equals 180 degrees. So solve for the measure of angle B. We get the measure of angle B plus 131 equals 180. Subtracting 131 from both sides, the measure of angle B is equal to 49 degrees. So we did have to find another measurement before we find the answer to this problem. So we replace the measure of angle B with 49 right there and right here. Now we can use this center ratio because we have both the numbers in it, and we're looking for side C. If we were solving the triangle, we'd have to find C and A. So we're really not interested in A on this particular problem. So we're going to take these two set up our proportion, just copy it down, 150 over the sine of 49 degrees equals C over the sine of 60 degrees. In a proportion, you can use cross products. So we use cross products. We get C times the sine of 49 degrees equals, cross multiply this way, 150 times the sine of 60 degrees. Solving for the variable C, since it's being multiplied with the sine of 49 degrees, we divide both sides by the sine of 49 degrees. On the left side of the equation, the sine of 49 degrees cancels with itself, and C is equal to 150 times the sine of 60 degrees over the sine of 49 degrees. Now to calculate this and get an approximation, in your calculator, 150 times the sine of 60 degrees, close parenthesis, don't forget that, divided by the sine of 49 degrees. That gives us approximately 172.1 meters long. So the bridge is about 172 meters long, right here.